Okay, so video 2. So this is a fun trick, and I like I think it was my thesis advisor who said any trick used twice is a method. So this is actually a standard technique, and when you first see it you will think it is a trick. Okay, so I'm going to say e to the x is t, so e to the x squared is e to the 2x, otherwise known as t squared. So the trick here is to see this 2x and this x and realize that when you square e to the x you get e to the 2x. So this is actually just a polynomial. And then you can factor this or do whatever else. You can use a quadratic formula. So then t equals 1 or t equals 2, but you're not done because you have to go back to this format. E to the x equals 1, e to the x equals 2. Now you have to take the natural log of both sides. X natural log of 1 by x equals 0. Okay? So it didn't take that long, so I guess I didn't need to make a new video, but maybe this is good because then people will start fresh on this video, right? Hopefully. Alright, next question. Alright, again, you just take the natural log of both sides in order to release this exponent, and then we just solve for x. I don't like 4x being there with the minus sign. Very easy. In my notes I was going to talk to you about inverse functions. We already talked about inverse functions in class, but I'll just mention it again here. That if we have sine, remember what I did in class? I had you fold the paper like something like that. And then what we ended up with was this crazy little, we ended up with this crazy little swirly thing. It was kind of pretty, right? But the point is, if you're going to do a sine function and then you're going to want the inverse of it, this is a good piece of sine to invert, because we want to be able to invert something that is, we need to pass the horizontal and vertical line tests on invertible section of sine of x. So we pick a piece that can be inverted, and then we invert it. And so what we have here is, since this goes pi over 2 minus pi over 2, then this is pi over 2 minus pi over 2. Okay? And since this was 1 and 1, this is just going to be 1 and minus 1. Okay, so arc sine has to fall between, I should use capital A because capital A means the primary piece, and this is the primary piece. It falls between minus pi over 2 and pi over 2. I think the equals goes on the right. There we go. The equals should go on the right hand side, not on the left hand side. Okay, and we have a very similar thing happening for cosine. Here we go. So cosine, we have the primary chunk of the cosine curve, and then everything else, right? And then we're going to invert it. So let's see. So we're going to try to invert this. And then what happens? We have this funny thing going up like this. Well, it's kind of, if you do it right, it kind of looks like horns on some kind of animal, right? Very silly. It's a face, like it's a girl with pigtails or something. Alright, so our cosine is going to go from 0 to 1, but then this guy's going to disappear, right? Because it would make more sense to include this point. Actually, let's see. We include both endpoints. We include both endpoints in both cases. What am I talking about? There we go. We include both endpoints. Hello. Okay. And what about arctangent? Well, let's see. Arctangent. Remember, tangent goes from, let's see, pi over 2 minus pi over 2. This is what tangent looks like. So arctangent is going to look like this. There we go. This is still going to be 45 degrees, but it's just going to go up like this. Alright. So it's still going to be 45 degrees, and then it's just going to flip along that y equals x mirror, which if I draw it, there'll just be one more thing on the screen. Okay, so there's not really much to say about that. Use of trig with inverse function in solving for x. Okay, I'm going to write that down. Okay, so I want to use trig and inverse trig in solving. So for example, I have a question that says simplify tan of arcsine of x. And so what does that mean? Well, what I do is I draw myself a triangle. Try to draw myself a triangle. Okay, so I just have a typical triangle. This is a unit circle triangle. I have cosine down here, sine over there, and an angle whose sine is x. So here's the crazy part. We're used to putting y over here and x over here, so don't let that bother you. It bothers me. So I'm sure there's somebody there for whom it bothers. If this really, really bothers you, why don't you just turn this x into a t? You can turn it into a t temporarily, and then at the end of the problem, you can undo this thing, okay? But I'm going to try to leave the variable the way it is. So an angle whose sine is x, so that means x is actually on the side we normally label y, okay? And we want tangent, so we want sine over cosine. So what we need is cosine in terms of x. So we know that sine squared plus, and I don't know what cosine is, so I'm going to call it q for question. Sine squared plus cosine squared equals 1. We're solving for q. Okay, so what this is, we don't need it anymore, we just solved for it. So it's 1 minus x squared all under the square root. Now we want tan. Tan is sine over cosine, or y over x. So tangent of this guy, and so this is the angle, we can just label it as theta, meaning whatever angle it is that we're talking about. Okay, so then the tangent is sine over cosine. And that's correct. You may say, oh gosh, let's do that again. Yeah, well, why don't we do that again? Okay, same heading, we're just going to do this a different problem now. So we want to simplify tan of angle whose secant is 4. Okay? Is 15. Oh wait, I'm sorry, not 15 squared. I'm asking myself. I put the answer down in my notes. So I want to simplify this. Okay. So again, I draw myself a triangle. And angle whose secant is 4, this is the theta. So again, I'm going to make the hypotenuse, well, I'm not going to make the hypotenuse one because that will make it annoying. Secant is equal to 4, then what's the reciprocal of secant? Well, I don't know. Sine, cosine, tan, cotan, secant, cosecant, and our reciprocals are nested this way. So the reciprocal of secant is sine, so cosine is 1 over 4. Cosine is is x over r. So here's x and here's r. Great. And so I solve for this guy. All right, it has to be what? A squared plus b squared equals c squared. Okay, so this guy here is equal to the square root of 15. Good. So now what do? But it asks us for the tangent. So tangent of theta is y over x, and so that's just square root of 15. You may want to see one more of those. Okay, so let's say we want to simplify another one of these. Simplify cosine of 2 inverse tan x. Okay, so this is a tricky one because you need both a triangle and additionally you need your double angle formula, your cosine of 2 theta formula. Okay, so we have cosine of 2 times an angle whose tangent is x. Okay, so angle whose tangent is x is going to be what theta is. Tangent is y over x. So the picture is going to look like this. That makes this calculation really easy. Okay, but now we need to unwrap this and we're going to have to look at this formula. And this formula, like I said, you should be able to look it up. Would I expect you to figure out that you have to use this two-step process? Only because I'm showing it to you now. Okay? So cosine squared of theta minus sine squared of theta, and so the cosine is 1 over, so cosine is x over r, and I don't want to use those letters, so now you might want SOHCAHTOA. And sine is y over r, so this is what you would expect. And finally you get this expression. Okay, so this is tricky because you had to use this formula in conjunction with this. So it's, again, this is the kind of problem that, now that I've shown you, I expect you to be able to handle it, and you might have to ask for this formula. But if I, for example, if I gave you a crib sheet and said you can write down formulas on a sheet of paper, that would be for crib sheet or given on exam if no crib sheet available. Okay, so if you're allowed a crib sheet, I'd expect you to crib that formula, and if you're not given a crib sheet, I'd expect you to ask for that formula or be given it.